Hi guys, welcome to my 5th episode of Love the Byte series. My name is Samuel Kamochu, a telecoms and software engineer for the last 13 years. I'm also the co-founder and the lead pace setter at Meliora Technologies. In this video, my objective is to help you appreciate the possible values given the number of bits. And I'll also try to ensure that you get to understand why this is important to you as a software engineer. In the previous episode, we talked about how transistors can be used to store information or digital information represented in binary format. We saw that if you have 8 transistors, it's possible for you to store a minimum value of 0 and a maximum value of 255. That means that an 8-bit number has the same value range. That is 256 possible values. Allow me to just illustrate some number conversions with a 4-bit number. So you have 0, 0, 0, 0. You know the place value of, from the right, we have 1, 2, 4, and 8. And this gives us 0, 0, 0 represents a 0. 1, 1, 1, you know the place value again. And that basically represents a 15. When you look at another number, 0, 1, 1, 0. So looking at the place value, the 8 is not there and the 1 is not there. So you're left with a 4 plus 2, which gives us 6. So if you ever see 0, 1, 1, 0, it should be possible to determine that that's a 6. So from this slide, you can tell that the value range for an 8-bit number, sorry, a 4-bit number is 0 to 15 or 16 possible values. Now let's look at a table that will help us appreciate these even more. If you have a 1-bit number, the possible values are either a 0, the minimum, and the maximum is a 1. If you have a 4-bit number, the minimum is when all the bits are set to 0, which gives us a 0 in decimal, and when all the bits are set to 1, which gives us a 15, which is basically what we covered in the previous slide. If you note, compare the 2 to power n together with 2 to power n minus 1, and you'll see some formula. So let's look at 8-bit, 0 to 255. If you take 2 to power n, it gives us 256, which is 2 to power 8. And if you subtract 1, then you get 255. You can do the same for a 32-bit, which gives us a 4 giga or 4 billion sort of. And that gives us the maximum value as 4 billion and so many other values ending in 295. So from there, you can tell that there is a formula, and let n be the number of bits. The minimum value will be when all the bits are set to 0, and the maximum value will be when all the bits are set to 1, which technically results into 2 to power n minus 1. So the number of possible values are basically 2 to power n, and we can illustrate that with a 16-bit number. So you can confirm that the minimum value is 0 when all the bits are set to 0, and the maximum value is 65,535 when all the bits are set to 1. That gives us 64,536 possible values. If you use our formula, then the figure becomes correct. So because you know that, I will allow you to just do some basic conversions, and I've given you the place values for you to get a hint. So you can pause the video for a few seconds and then resume. I hope you've done the computations by now, so I'll display the answers. So the first value is 171 in base 10, and the maximum value in 11 bits is essentially 2047, which you can use the formula to compute the same. Some of you might be wondering why we are learning this. It's very important in the life of a software engineer. And the first example will be, let's look at TCP Header, which is a protocol that we'll cover later. The source port is a 16-bit number. And from that, the possible values are from 0 to 65, 535. So do not expect a port number to be 70,000 or even a negative value. Same case, you can look at the sequence number, 32-bit. That gives us about 4 billion plus possible values. So if you have a sequence number of 8 billion, it cannot be represented in this TCP protocol. Again, let's look at Internet protocol. We will look at the version, which is a 4-bit number. If you look at the diagram, and the common possible values are 0, 1, 0, 0, which by now you should know it's a 4, 0, 1, 1, 0, which is a 6. And if those values are set, then it means IP version 4 and IP version 6, respectively. You can also look at the source address, which is the source IP address. It's a 32-bit number, but normally we look at it as 4 8-bit numbers. And 4-bit, the possible values are from 0 to 255. And that's why we know that an IP address in version 4 has 4 parts, and each of them can have a value of 0 to 255. Again, you've also heard about address bus, 32-bit or 64-bit or 16-bit, 4-bit. That means the possible addresses in a 32-bit bus is 2 to the power 32, which gives us 4 giga. So if each location stores a byte, something that we'll study in the next episode, it means that a 32-bit bus can only address 4 gigabytes. So in the event you put 8 GB RAM in a 32-bit machine, then definitely you'll have half of that not being addressable in a 32-bit machine. Another good illustration where this information comes in handy is when you're programming. If you declare a variable as an integer in Java, Java stores that as a 32-bit number, or what we call 4 bytes. So if you used unsigned values, then you have 0 to 4, slightly above 4 billion. And if you're using signed, it's negative 2 billion to slightly above 2 billion. So the 1 bit is used for the sign, whether plus or minus. So in case you're representing a 6 billion number, do not use an integer. Or you think it could be beneficial to someone else, please share and feel free to like, comment, and subscribe. Thank you very much, and see you again in the next episode.